Hi everyone, this is Professor Collins and we are going over an Excel workshop today. And so today we're going to be talking about the chi-squared test, chi-squared significance test. So chi-squared tests are used when you have nominal types of variables. And what we're going to do today is we're going to calculate and interpret the goodness of fit chi-squared as well as the chi-squared test of independence. Now, using the test of independence, what we're doing here is we're examining the relationship between two categorical variables. Whereas the goodness of fit test is we're examining whether the frequencies in the categories of one variable are equivalent across those categories. So where the test of independence is two categorical variables, goodness of fit is just one categorical variable. So let's start out with our goodness of fit test. So we'll start with this, our goodness of fit chi-squared. And as you see here, we have our variable, and our variable is Halloween costume type, and it's a categorical variable. And we have different types of costumes, right? We have ghosts and ghouls, that's one, superheroes, revealing costumes, and other types of costumes. So let's say we just sampled randomly in the neighborhood and placed people into these different categories. And so our research question here is we're interested in, does the types of Halloween costumes vary across those different types of costumes? And you can see here our chi-squared obtained formula, and we'll go over that in a little more detail. So our chi-squared test of independence, we have to state our assumptions. Those are fairly basic and typical. State our hypotheses. So for our null hypothesis here, for our test of our chi-squared goodness of fit test, is that there's no difference in costume types. So the frequencies are the same across each costume type. The research hypothesis is that there is actually a difference in costume types. So some people wear more of the same type of costume than other types of costumes. We need to establish our critical region in step number 3 here. So we're going to use the 0.05 alpha level. And our degrees of freedom is k minus 1. In this case, k stands for the number of response options, or number of categories, right? So we have 4 categories here. We have ghouls as one category, superheroes is another, which is 2. Revealing costumes is 3, category 3, and category 4 would be other types of costumes. So our degrees of freedom here is k minus 1, or 4 minus 1, and that'll help us find our critical region, our chi-squared critical region, which is 7.815. Now we need to compute our test statistic. Now this is where Excel is not as helpful as maybe some of the other statistical programs. And that's because in Excel, as we've been using our data analysis pack here for some time, the data analysis pack actually doesn't have a chi-squared function. So we have to calculate all of our bits of information by hand, right? Or we can sort of cheat a little bit and use some of the functions in Excel to calculate that for us. So what I'm going to do here is I already have sort of a results section queued up, and I've done this with pivot tables. Now if you don't know what pivot tables are, you can see them in some of the other videos. There's lots of videos on how to do pivot tables. So I'm going to click in my pivot tables here, and I'm interested in Halloween costume type. You notice I spelled that wrong. Halloween has 2 L's. So I'm going to go ahead and click on the Halloween costume type, and it'll put it right down in row labels. Then what I'm going to do is I'm going to take this and drag it down into values. And we want to make sure for the value field settings, we want to make sure it's a count, right? It's counting the frequency of each costume type. And as you can see here, we have 30 ghosts and ghouls, we have 5 other, we have 6 revealing costumes, and we have 7 superheroes. So, in effect, these are our observed frequencies, right? Now what we need to do is calculate our expected frequency. So I'll go ahead and place that there so you can sort of see what we're doing. And our expected frequency, if I'm to add this or to sort of show you visually what this is our expected frequency is n, or our sample size, divided by k, which is the number of categories, right? And so we can see here that our grand total, our sample size is 75. So in each one of these I can do equals 75 divided by 1, 2, 3, 4 categories. 4 categories. And that is our expected value, right? And so we should have the same expected value for each one of, or expected frequency for each one of our categories. Now what we can do, and I'll place this here so you can see how that's calculated, sample size minus k. Now we need to calculate a piece of our chi-squared statistic. So this is just one piece of the chi-squared statistic. And so what we're doing here is we're taking the frequency of the observed minus the frequency of the expected frequency, squaring that and dividing that by the expected frequency. And so the nice thing about Excel is we can do this using formulas, right? So what we'll do is we'll do equals, and I'll do 2 parentheses, and you'll see why in a minute. And I want to do the frequency of, so we have to do this for each category, right, or for each one of our cells. So I'm going to start with the frequency of the observed, and so in this case we're looking at cell B4 minus cell C4 times the same thing, right? So you can do squared. It's a function called power in Excel, but when you're just doing squared, it's easier to times the formula by itself. And we'll just type that in again: B4 minus C4, close those parentheses, divide that by C4. All right? Or just to show you to type it in, C4. There we go. Now we have 6.5. So that is this formula here, and we'll drag this down. So the nice thing about Excel is it can copy and paste. Now we need to, if I go back here, we need to get this formula here. So we have our chi-squared obtained formula, which is the sum of all of these, right? And so now what we can do is we can sum all of these scores, and that will give us our chi-squared obtained value of 19.66666, right? So now what we do is we compare that 19.66 to our critical region, right? So let's go in here and we'll say, I'm just going to steal this, make it easier. Going to say chi-squared. Does not like it formats it for me. That's obnoxious. So chi-squared obtained equals 19.666, right? I'll do an extra 6. And now what we're doing is we're comparing this 19.66 to our critical region. If this 19.66 is greater than our critical region of 7.16, or excuse me, 7.18, then we can reject the null hypothesis. So in this case, we're going to reject the null, and I'll strike that through, reject the null, and accept the research hypothesis. So the way to interpret this is you can say something like a chi revealed that oops, I'm on test of independence. We're going to this one, aren't we? So let's copy this because we're going to the other one. We're looking at our goodness of fit. I don't know why it does that. So we can say our chi-squared analysis revealed that there is in the frequencies of Halloween costume types with, and we can actually go look at the data, so we can look at our results with Ghosts and ghouls being the most frequent. Ghosts and ghouls. We can put n equals 30, right? So that sort of tells us, it gives a more layperson's description of what we actually found here. And so we can say a chi-squared analysis revealed that there's a significant difference in the frequencies of Halloween costume types, with ghosts and ghouls being the most frequent, right? So this lets us know the number of people who wore ghosts and ghouls as opposed to other things, right? So that's sort of our chi-squared goodness of fit. So again, we're just looking at one specific variable. Now let's take a look at the test of independence. So we're going to look at this. I'm going to delete that because that was a typo on the wrong place. Take this out. Let's remove that strike through. Now we can start here, right? So now let's take a look at our chi-squared test of independence, right? So we have our results here, and actually what I'm going to do is I'm going to copy this. Create a copy. There we go. So I'm going to copy this so we can just jump over here for our test of independence. So now let's take a look here. We have the same assumptions for our test of independence. Our null hypothesis is going to be a little different, right? So let's start at the beginning here, actually. We have two variables, Halloween costume types and weather. So maybe we're interested in, there's a relationship between the weather and type of costume. So maybe people don't wear quite as revealing costumes when it's colder compared to when it's warmer, right? So we can actually test and see if there is a relationship there. So we have to establish our critical region. The critical region for test of independence is slightly different. We want the number of rows and the number of columns. And so the way we can identify that is the number of categories for each variable, right? So variable 1, let's assume they're going into the rows. We have 4 categories, again, like we talked about last time with the goodness of fit. Category 2, or variable 2, we have weather, which has 2. We have warm and cold weather, right? And so we can use that information to calculate our critical region. And fortunately, our critical region is the same as our test of independence, so we have the same critical region. Now we need to compute our test statistic. So let's go take a look at our results here. And I'm actually going to undo this. Well, I'm going to delete all of this, so that way we can sort of start fresh. So I'm going to get rid of this, right? So what we have to do, unfortunately, is we have to use our pivot tables, again, to sort of create our rows and our columns. So let's click on a Halloween costume type. That'll be our row. And then for our column, we'll put that in the weather column, right? So we have cold, warm, then we have ghosts and ghouls, other revealing costumes, and then superheroes. Then what we can do is we can take actually either one of these variables and bring it down into the value section. And again, we want to make sure that our value field settings are set to count, right? And this will give us the frequencies across both of these variables. So the cool thing about this is we can see that there are 18 people who wore a Ghosts and Ghouls costume in cold weather, whereas there was only 12 in warm weather. And it gives our grand total for each. So the nice thing about this is, and I'm actually going to move this out of the way, bring it down here for now, and I'll bring this down here for now. The nice thing about this is actually our row totals. Excuse me, let's do that again. So this grand total is actually our row totals, or RT, and this grand total down here is our column totals, or CT. So these are important because they're needed, right? So what I'm going to do here is I'm going to borrow this, and I'm going to put it down here, and I'm going to borrow this, and I'm going to put it here. So now what we need to do is calculate our expected frequencies based on our row totals times our column totals. And so the way we do that is our expected frequencies in this case, and I'll put this down. Actually, steal that, bring it up here, expected frequencies. The way expected frequencies are calculated is row total times column total divided by n. And our n here is the 75. So the nice thing about this, what we can do is we can calculate our expected frequency for each one of these. And the way we do that is we can do enter, and we can find our row total for ghosts and ghouls, which is 30. And what we can do is we can just we can take that number, which is E5. We can take that cell just so you see where it's coming from, times our column total, which is 44. So we can take that as B. What is that? 10. Right? Divided by 75. So since our n is going to be the same for every single one, we can just keep that as standard, right? So what I'm going to do here to keep this at the same place, actually, I'm going to move. Which one do I want to move? I'll keep this one. Okay. So these little dollar signs is going to keep that cell in the same place. So I'm just going to bring that down, and as you can see there, it holds to where it's supposed to be. Right? So it helps us calculate each of our row totals and our column totals. So now what I'm going to do is I'm going to do the same thing for this. Equals, so we have our row total of, what is that again? E5 times our column total now of C10, right, divided by 75. Okay, and then we can do the same thing here where we're holding C10 in place, and we're going to drag this down. Right? So it's a lot of work to identify your expected frequencies. But now we have our expected frequencies, right? So now that we have our expected frequencies, we can now calculate. So I'm going to create one more little chart here. Now we can calculate this little piece here. So what I'm going to do is get rid of that. And what we can do is we can now calculate this formula here for each of our cells, looking at these two tables, right? So here's what we'll do: is we'll do our equal sign, 2 parentheses, and we want our observed frequency, which is our 18 here, or B5. Minus our expected frequency, this guy here, times, that's a plus, times B5 minus our expected frequency, close parens, divided by our expected frequency. Right? So now that we have all that, the nice thing is we can drag this down, and we can drag it over, and it automatically fills in all of those formulas. So you can double check this, right? Just make sure it's coming from the right place, and there we go. So now we have all of these whole formulas, right, for each one of these, and now we can calculate our entire chi-squared, and we do that basically by summing all of these, right? So that's what this big sigma is. When you see this big sigma, it means summing all of those equations. So I'm going to go sum, close the parentheses, and there is our chi-squared. Our chi-squared obtained, right? Is right there. So we can take this now and go to our test of independence. And what was our, actually, so I have this was 7.769. So our chi-squared obtained. What does that? Chi-squared obtained equals 0.769. So as you can see, this is not greater than our critical region. So we reject the research hypothesis or we accept the null hypothesis, right? So in this case, I would simply state there is not a between and type of. Right? So there's not a relationship between weather patterns and type of Halloween costumes. So this is our sort of overview, our real kind of quick overview of chi-squared analysis, both test of independence and goodness of fit. And the nice thing about this is you can use your pivot tables to help you calculate your cells here, your rows and your columns. Alright, so this one, by the end of this, you should understand at least how to examine or how to do a test of independence, as well as goodness of fit in Excel. Alright, thanks for watching.